Assalamu alaikum. My name is Dua Samman and today I am going to explain the topic the complex number. Although I know all of you must be aware of this topic, but let's just recall some of the basic of this topic. So what actually complex number are? Complex number are sum of real and imaginary numbers. For example, and it is denoted by z as you can see. For example, z is equals to a plus iota b. So here a is the real part while the number or the alphabet with iota is called the imaginary part, where a and b are real numbers. This was just a small definition of complex number. Let's move further on to Argand diagram. So this is called the Argand diagram. Here you can see there are 2 points. The O is at the origin, and let's consider point P. The vertical line is known as y-axis, while the horizontal is called the x-axis, and it is making an angle theta with the origin. And z, here z, this is called modulus of z. I'll explain it further in a few minutes. Well, okay. The line which makes 90 degree is called the perpendicular, while the line opposite to the perpendicular is called hypotenuse, and the line with which the theta is made is called base. So let's suppose an example. If let's suppose a complex number such that z is equals to 3 plus 2 iota. So we can say that 3 will be denoted on x-axis while 2 will be denoted on y-axis. So I discussed with you earlier about the modulus of z. So this is the formula. This is called modulus of z, and this is the formula of modulus. It's very simple. It's just under root x square plus y square. It means under root square of the real and imaginary part. So here you're not concerned with the sign. You'll just have to directly add their squares. So we can see, for suppose 3 and 2 are the real and imaginary part. So we can easily find the modulus. Under root 3 ka square plus 2 ka square, which gives us 9 plus 4, that is equals to 13. Now let's talk about angle. How to find the angle? It's very easy. We can use the tangent formula to find the angle. You all must be aware of that code. We can say it a code, which was like all people have curly brown hair through proper brush. So that way you can remember. So tan theta is equals to proper brush perpendicular upon base. So you can see here the perpendicular is y-axis. So y upon, and x is the base, so base is equals to x. So tan theta is equals to y upon x. But what we are concerned here is for the theta. So we have to find the theta. So we'll send the tan on the other side. Then it will become theta is equals to tan inverse y upon x. Let's take a few examples by plotting these complex number on the graph. First, suppose the first example, you can see that we have a complex number whose real part is 2 and imaginary part is minus 3. So it's very easy to plot. First of all, wait, I'll show you how the quadrants are actually divided. So you may have a look. So 1 second, it's a bit blur. It's fine right now. Okay, so it's divided into 4 quadrants, as you can see. First quadrant, second quadrant, third quadrant, and fourth quadrant. The vertical line is called y-axis, while the horizontal line is called x-axis. And as you can see, this side is positive x-axis, while this is negative y-axis, and the y-axis above the line is positive, while below the line is negative. So now you should remember that this is first quadrant, second quadrant, third quadrant, and fourth quadrant. Well, let's come back. So I was telling you how to plot this on the graph. So you know that positive 2 on x-axis is here, while negative 3 on y-axis is here. So the point must be lying somewhere here. So you can see it's in the 1, 2, 3, and 4. So it's in the fourth quadrant. Let's have a look on another example. So here I have minus 1 on x-axis and 2 iota on y-axis. So it's very easy to plot. Negative x-axis is here, so -1 is here, and positive y-axis is up here. So the point must be somewhere lying somewhere here. So you can see it's the second quadrant. Okay, let's move further on conjugate of a complex number. Okay, so what exactly conjugate of a complex number means? It's very easy as a pie. You will understand why I'm saying so, because complex number with the same real and imaginary part as original, but only the sign with the imaginary part becomes the opposite. See, I told you it's very easy. For example, just suppose that the complex number z is equals to x plus iota y. It's the real complex number, and you have to find the conjugate of this number. Conjugate is represented by a line on the letter. As you can see, z conjugate means a z with a line on it. So its conjugate will become, just change the sign of the imaginary part. So here the imaginary part is iota y, right? So, and it's with a plus sign, so just change the sign. So it will become z ka conjugate is equals to x minus iota y. See, I told you it was easy as a pie. Well, now let's move further on properties of one second. So yeah, now we'll talk about properties of conjugate base. I hope it's clear. Yeah. So yeah, we have some properties of this conjugate. For example, you can see there is a double see the first, oh, I'm really sorry. See the first property. It's called, it says that z conjugate of z and another conjugate, means two conjugate of a z, is equals to the real z. If we take a complex number and take its conjugate and again take its conjugate, it will be equal to the real complex number that we actually took. Okay, I know it might sound a bit difficult, but let's see its example. First, suppose z is equals to x plus iota y. That's a complex number, you know that. Now just take its conjugate one time. So what it will become? Easy, x minus iota y. See, now take its conjugate again, because the property says double conjugate. When you will take double conjugate, this minus sign will again change in plus sign, and see, x plus iota y and the quotient x plus iota y. See, it's same. It means that when this property is proved, that when we will take the twice the conjugate of a complex number, then the original complex number will be retained. Okay, now let's have a look at the second example. So it says that modulus of z is equal to, if we take conjugate of a complex number and take its modulus, they both will be equal. Let's have a look. See, for suppose z is equals to x plus iota y. That's a complex number which is given to you, and now we'll take its modulus. Very easy, I told you, under root real part ka square plus imaginary part ka square. So it's easy, under root x ka square plus y ka square. Okay, you are done with the first part. This is the answer of z modulus. Now let's solve the right hand side. It says that take the conjugate of the complex number and then find its modulus. Okay, so our real complex number is x plus iota y. So when we take its conjugate, it becomes x minus iota y. And when we take its modulus, I told you before that whenever you find a modulus, you never see the sign. It's just simple as a pie. You add the real and imaginary part, square of real and imaginary part. Here also we did the same. When we find out the z modulus, so it became under root x square plus y square, and you can see the result of left hand side and right hand side is equal. So it means this property is also true. Now move on to the third property. So the third property say if we multiply a complex number with its conjugate, it will be equal to the square of the modulus of that complex number. No problem, I'll explain you in a bit. It's very easy. For suppose we took a complex number z is equals to x plus iota y. We'll find its conjugate also. Very easy, x minus iota y. Then we have to find z into z multiplied by z conjugate. So we will multiply these two. It's very easy. You can identify it quickly that we can use a formula here. It's a plus b into a minus b. So the formula is a square minus b square. So you can see z into z conjugate is equals to a square. It means x square minus b square means iota square y square. But don't forget that iota square is equals to minus 1. So z into z conjugate is equals to x square plus y square. Okay, so the left hand side is proved. Now you have to prove the right hand side. See, for right hand side, first you will find the modulus and then you will square that. Okay, very easy. So this was your question, x plus iota y. So you find the modulus of it, so it becomes under root x square plus y square, and then you find and then you square it. Oh sorry, and then you take a square of that modulus, so under root x square plus y square, and outside the bracket you square it. So this square and this root cancels out each other, so z conjugate sorry for the conjugate again. So z modulus square is equals to x square plus y square. This is the answer of left hand side and this is the answer of right hand side. So you can see these both are same, so hence proof.